Hey YouTube, Kevin Francis, astrophotographer, and welcome back to the next installment of my journey in astrophotography. One of the places where I left off was with my Orion ST80 and tilt, where I had solved my tilt problem, but still had the issue of egg-shaped stars randomly, sporadically throughout my imaging session. And I was throwing away a lot of images as a result of that. I even mentioned in that video that I was interested in purchasing a new mount, okay, a go-to mount. So full transparency, while I was down and out for 8 months, I did actually buy a mount that's been sitting in a box, and so more on that later as we go. But what I want to do today is I want to start pulling some threads. No, that's not what I meant, SpongeBob. I'm talking about these threads. I have resisted the urge or the ability to 3D print threaded connectors for my telescope. I've always thought that was difficult because they're so very small. And within the last few years, I've actually learned a lot more about 3D printing and what my printers can do. So I'm going to give that a go, because I think that's going to help my back focus problem that I do actually have with my Orion ST80. So if I can do this, if I can make it work, then it will open the door to a lot more 3D printed connectors that I can do for my projects, which means that I can actually start using my Meade ETX-125 with my camera, because right now I haven't been able to fit it on there without using a T-ring. Now I can start creating better connectors to allow me to put everything together on the image train properly. So this is what I'm looking into doing. Let's take a look. So real quick, let's take a look at the mount. It is the Skywatcher HEQ5 Pro. So this was covered up well over the snow and it survived, but as you can see, it is the Skywatcher HEQ5 Pro. And I've already run my wires on this. I've actually played with this a bit, even just an experience lesson learned is the SynScan Pro application that comes with this, or that you can download to run this mount, does not do meridian flips very well. It actually destroyed the power cable on an attempted meridian flip. So I run and changed over to EQ mod, and that has been perfect ever since I've done that. So just a little FYI for this mount. But I've enjoyed using it. It certainly makes life a whole lot easier for me, where I can easily just sit inside, hit a button on APT, and the mount just does everything it needs to do. And I wake up in the morning, it's done this meridian flip, it parks it, and it's all done. I go and I look at my data and then I process it. That's so much to talk about, I forgot to roll the intro. Here it is. Okay, for you it's a few seconds, for me it's the next day. So let's take a look at Tinkercad. Creating the threaded parts, not hard at all. So I'll walk through that here. The difficult piece has always been 3D printing it, so we'll do that next after this. Okay, here I am in Tinkercad, and I've already created the name or title of it as the 16.5mm back focus spacer, which is what I need. First of all, we need to create the threaded end. And so what Tinkercad has is what's called a shape generator, and it's called the ISO metric thread, which these are metric threads, and it gives you a sample of it. And so what we know is that the diameter is 42 millimeters. So that'll make it 42 millimeters. The pitch is 0.75 on the threads. All right, we'll do that. And now let's make this as smooth as possible, right? Because you can see there's some segments here, there's some flat edges all the way around. So let's go ahead and make this 32, which will start to smooth it out like that, okay? And that's basically it. That's really all we need. 5 rotations. It means it goes around the circle there 5 times. So that's more than enough. You're talking, let's see, 4.31 millimeters between, in this particular case, is going to be the field flattener and the filter. So that's more than enough. I think that would be fine. So now the fun part is the 16.5 millimeters of spacing that we need. So I'm going to just go back to the basic shapes. Take a circle, or a cylinder, sorry. Let's get this as smooth as possible. I want all the segments and sides I can get. And I want this diameter to be 42 millimeters, which is the diameter of this guy. Sorry, I don't want it to be 42. I actually want it to be bigger because I don't want it to slide into the field flattener, right? So I want it to be bigger. So let's get a good 5 millimeters of extra space there. 47. There we go. And so now I want to get this up 4.31 millimeters. So I'll kind of cheat a little bit here and raise that up like that, just by adding that little ruler, and then I can change dimensions as I go. And now let's put these two together. So I'll select them both, and I'll click on that and start centering everything up. And there we go. And I'll combine the two into one. And so now I have the threaded end on the bottom, which will, in this particular case, it can go on either side, the filter or the field flattener. And then I need one at the top. So now I got the 16.5 millimeters I'm looking for. I can let this ruler go. And now what am I missing? I'm missing a hole because, you know, light can't get through this solid piece of plastic. So let's put a hole in here. All right, so we know the outer diameter is 42 millimeters. So we want to be somewhere in that neighborhood. So I got a cylinder. I'm going to make this a pretty tall cylinder because I want this to go all the way through. And will it? Yes, it will. Fine. Now I have what I'm looking for. Okay, I've finished the design, and I will show you that in detail here in Cura. But before I do, one of the pieces that I may gloss over as I'm going through those details is that I want to make sure I 3D print this in the right orientation. So you know how 3D printing works, where you're putting down layers upon layer upon plastic. Well, when you do that, when you're talking about axial forces, meaning, let's say, the weight of the camera on those layer lines, it could actually separate at those layer lines and break. So thinking about the safety of the camera, and that this nice expensive camera that you have on the end of your telescope, you want to keep it on your telescope. So I'm going to be printing this spacer sideways so that my layer lines are going up and down. So that way the weight of my camera doesn't force this to fail and have everything sitting on the ground broken and destroyed or damaged, which would be bad. Anyway, let's take a look at my Cura settings. Then we're going to print. We're going to see if this all works. All right, so let's get down to it. So here it is. This is the 16 millimeter spacer. So I'm okay in printing it in this orientation because this is almost perfect circle. The printer will have no problems making that. So where I do have a concern though is this overhang at the bottom. I'm going to need some support. So I'm going to make sure that this has support, but I do have the concern that sometimes support is difficult to come out. So it may get stuck on those threads, which just means I'd have to print this thing over and over again, or be very careful with an X-Acto knife and trying to clean this up. But in any case, I do need it in order to print this properly. From a quality standpoint, or from a print quality standpoint, the layer height needs to be very small. And that's what's going to help get those threads printed and printed properly, even though they look very small themselves. So I've always thought that my printer couldn't handle these very small layer heights. So we're going to find out if it actually can. So Now with that, so the layer height here, but I also found out, again, hanging out on YouTube and learning from others, that you don't want that very small layer height on the initial layer. You want good adhesion to the bed, and I don't use glue. It's all glass for me, so a lot of these are the original glass that came with the printer. Most I use some alcohol to keep the bed clean, rubbing alcohol that is, or isopropyl alcohol, and that does a really good job with my prints and creates really nice flat smooth surfaces on those prints. So all right, that being said, I'm going to keep my initial layer height at 0.2. okay, and so that's the biggest change there that I needed to make in order to get this done. So let's go down here, and we're looking at supports. So I'm going to generate support. They're going to be normal supports, and I only want it touching the build plate. So that's basically going to put the supports down here from the bed on up to the threads on either side of this print. So if you want to take a preview of what this looks like, I'll click on preview, hide that for a second. And so down here in blue, these are the supports. So that's the support that's going to be showing and printed as it goes. And you can see there's even a little bit of support on the cylinder itself, the larger cylinder of this as well, just to keep that from falling down or having issues. But it's not needed. I really want it more so than anything else, because going left and right of center is an overhang, and there's not a good way for the printer to handle that. So okay, cool, that looks pretty good. Okay, so if I look down here at the bottom, it says 3 hours 24 minutes to print, so I will go ahead and do that. Okay, here are the results so far, YouTube. Still working at it. It's not perfect. Got 4 different versions sitting here. The first 3 you see here were printed in the orientation that I've told you before, in terms of layer lines, not having them in stress points so that that it fails in usage. And so this is liftoff. Okay, this one is where the bed adhesion, it didn't stick very well to the bed, so it lifted off on the corner, and so then of course this wouldn't finish. So that's that one. Then we got a little black hole emulator here that spaghettified completely the entire, or most of the print before I noticed it, and it just didn't do anything. The third try printed most of the way, and then it got to the top here and said, I'm done. Started sliding all over the place. So didn't finish. Now this one, I was able to pull the support material off that I needed. Looks kind of wonky down there. I may not be able to, if it did finish, I may not have been able to get this to attach to telescope. So I gave up a little bit, because the goal here is to see if I can actually print threads. And so here is one that was printed in this orientation. Again, layer lines are in stress points, but again, goal is to see if it will print threads, and it did. They look really nice. See if I can, it's black, I just know that's probably hard to see for you guys. But I have another adapter that I purchased a long time ago. It's got the right dimension, so here's the moment of truth. Let's see if these threads work. Put that on there. Oh, look at that, it fits. And oh, it's going in there. If I can put it in there straight, haha. But it actually, it feels good. Let's see. There we go. Look at that. Complete attachment. And it's solid. It's all the way to the, all the way down, all the way to the end. It's solid. I'm going to try and stress it, see if I can actually break it, because if I can't break it, I can print in this orientation and it would be acceptable for use with my telescope. So I think a stress test is involved here, but this is pretty cool. I'm actually able to print thread. This is actually pretty cool. I like this. I can print threads. It's perfect. Oh my gosh. Okay, so wow, with something like this, with the ability to print threads, and I'll off camera, I'm going to stress test this and just give you the results. But I tell you what, I've got this new mount now, right? I'm sorry, EQ5 Pro mount that will allow me to do guiding. And I'm betting that if I can attach my USB camera, that because I have this observatory now, it's not being used very often, I can put it on my finder scope, create a guide scope. I just have to figure out how to connect it back to the mount so it can guide the mount with PhD2. This is revolutionary for me. Just printing threads allows me to do some things now without having to go buy a whole bunch of stuff. That's awesome. Anyway, I can't contain my excitement here. Just want to I want to get started. So tell you what, you guys remember it. The sky is only the limit when your mind is unwilling to fly, so go beyond. Thanks for watching. Kevin Francis, Astrophotographer. Don't forget to subscribe. See ya.